MegaCorp's sandbox account quietly climbed to 180,000 euros a month. No tags, so nobody could say which team spent it. No alerts, so nobody knew until the invoice landed. And no reservations, so it was all full price. 6 different questions were going unanswered, and Amazon Web Services has a distinct tool for each one. Cloud Architect Path, Episode 34. Stack Lessons Rolling. By the end of this video, you'll know exactly which Amazon Web Services cost tool answers which financial question, so you never confuse analysis with alerting again. This is the Design Cost Optimized Architectures domain, and it rewards clean tool selection over configuration detail. In the last episode, we used Compute Optimizer to right-size MegaCorp's idle EC2 fleet before committing to savings plans. That was just one tool pulled from a much larger cost management toolbox. Now we're going to map the whole stack, the full practice of financial operations, or FinOps, and learn which tool answers which financial governance question. Before we get into the mechanics, 5 terms carry the weight of this entire episode. Cost Explorer is the free console tool for visualizing and forecasting your spend. Amazon Web Services Budgets goes a step further. It alerts you and can take automated action the moment spend crosses a threshold you defined. The Cost and Usage Report is the most granular billing dataset Amazon Web Services produces, landing in your own S3 bucket as raw line item rows. Cost allocation tags are the key value labels that connect resource spend to a specific team or environment. And Compute Optimizer is the machine learning service that reads CloudWatch metrics and recommends precisely which instance types to switch to. Here's the thing about a runaway bill. It's not one problem, it's a stack of unanswered questions. What did we actually spend? And on what? Can something warn me before we overspend? Which team caused this? What should we resize? And what's just sitting idle and forgotten? Amazon Web Services ships a distinct tool for each of those questions. The skill is knowing which one to reach for. Give each tool a single one-line job, and this whole topic gets simple. Cost Explorer visualizes and forecasts your spend. Amazon Web Services Budgets fires threshold alerts and can take action. The Cost and Usage Report gives you the granular line items. Cost allocation tags attribute spend by team or environment. Compute Optimizer does machine learning right-sizing, and Trusted Advisor runs best practice checks for idle resources. Notice the 4 jobs underneath: analysis, alerting, attribution, and optimization. Each tool lives in one of those buckets. Start with Cost Explorer, the analysis layer. It's a free browser tool right inside the billing console, and it visualizes up to 14 months of daily cost and usage. You filter and group by service, region, account, or tag to find your top spenders. It'll forecast spend up to 18 months ahead using an 80% prediction interval. It even surfaces some EC2 right-sizing and reservation recommendations. But the one thing to burn in here is that Cost Explorer is passive. You go and look at it. Here's the analogy that keeps these two straight. Cost Explorer is your bank's app, where you scroll back through months of transactions, filter by category, and watch a trend line. Amazon Web Services Budgets is the spending cap you set on your card that texts you the moment you cross 80%. One helps you understand, the other warns you. Line them up side by side. Cost Explorer is passive. You open it, and it answers what did we spend and why through trend lines, filters, and forecasts. Critically, it has no notification mechanism at all. Amazon Web Services Budgets is active. It comes to you answering "warn me before we overspend," with threshold alerts on actual or forecasted amounts, and it can even trigger automated actions. Both deal in money and forecasts, which is exactly why they get confused. Only one of them sends you a notification. So Amazon Web Services budgets is the alert layer. You can set budgets on cost, on usage, on reservation utilization, or on savings plan coverage. It alerts on actual or forecasted spend and delivers that alert by email, by SMS, or through chatbot into Slack or Chime. On pricing, monitoring and notification-only budgets are always free. Action-enabled budgets get a small free tier too. Your first 2 action-enabled budgets each month cost nothing. Beyond those 2, each additional action budget runs 10 cents per day. The clearest signal for choosing budgets over Cost Explorer is intent. If the requirement is to be notified or alerted when spend crosses a threshold, that is always budgets. Cost Explorer has no notification mechanism. Budgets doesn't just talk though. It can act. With budget actions, the moment a threshold breaks, it can automatically apply an IAM policy or a service control policy that blocks new provisioning, or even stop EC2 and RDS instances. For MegaCorp's sandbox, that means when the account hits its monthly ceiling, an SCP shuts down further spinning up automatically, with no Lambda function involved. One caveat worth remembering: those SCP actions get reversed at the start of the next budget period, so if you never fix the root cause, spending resumes. The Amazon Web Services Budget's best practices documentation puts it plainly. Amazon Web Services needs roughly 5 weeks of usage data before it can generate a forecast. So if you configure a budget to alert on a forecasted amount, that alert stays quiet until enough history is accumulated. On a brand new account, forecasted spend alerts simply won't fire for the first month or so. Actual spend alerts work immediately. The warm-up period only applies to forecast-based alerting. Quick recap before the next pair. Cost Explorer looks back and forecasts forward, and it's analysis you choose to open. Budgets is a limit that reaches out to you when it's crossed, and that's alerting. Both deal in money and forecasts, but only one sends a notification. Now, here's the problem neither of them solves on its own. Neither can tell you which team actually spent the money. This was exactly MegaCorp's situation. The sandbox invoice came in as one giant lump sum, with no breakdown by team or project. And Cost Explorer can only group costs by a tag if that tag actually exists and has been activated. Cost allocation tags are just key value labels you attach to resources, like team equals payments or environment equals sandbox. Without them, every single report shows one enormous untagged bucket. That's the blind spot. Practitioners find that in messy multi-team accounts, untagged spend routinely runs 30 to 50% of the bill. Picture a company where every purchase goes onto one shared credit card. At month end, you get a single statement and no idea who bought what. Cost allocation tags are like a finance rule that every employee writes a project code on every receipt. Suddenly, you can sort that stack by team, by environment, by application, and see exactly what each cost center spent. There's a subtle step people miss. Tagging a resource is not enough. You have to explicitly activate the tag in the billing console, and only the management account can do that. And the Amazon Web Services documentation warns it isn't instant. After you apply the tags, it can take up to 24 hours for the keys to even appear on the activation page, then up to another 24 hours to actually activate. So plan for up to 2 days before that tag shows up as a filter in Cost Explorer. And here's the part that stings. Tags are not retroactive. They only attribute spend from the moment they're applied and activated onward. Every euro MegaCorp spent before tagging existed is permanently unattributed. You cannot go back and reassign it. In a large account, even a single day of untagged spend can mean thousands of euros you'll never be able to break down. The lesson is, tag from day one, not after the bill scares you. Now, When you need to go deeper than a dashboard, you reach for the cost and usage report. It's the most comprehensive billing dataset Amazon Web Services offers, delivered as CSV or Parquet straight into your own S3 bucket. Every row is a single line item: the product, the usage type, the operation, the specific resource, and its tags. You query it with Athena, load it into Redshift, or visualize it in QuickSight. Think of the CUR as the raw data warehouse sitting beneath Cost Explorer's dashboard. In fact, for a big account, a single report can top 1 million rows and get split across multiple files, which is exactly why you need a query engine, not a spreadsheet. Amazon Web Services is unusually direct about this one. The cost and usage reports documentation states that the report contains the most comprehensive set of cost and usage data available. So when a scenario asks for the most granular billing data, or line item detail, or querying billing with Athena, that phrase points straight at the CUR. There's nothing below it. So don't treat these two as interchangeable. Cost Explorer is a visual, console-based dashboard with 14 months of daily history and a free interface for quick analysis with no setup. It's the manager's summary view. The cost and usage report is a raw dataset delivered to S3 with unlimited retention and resource level detail, queried through Athena or Redshift. That's the engineer's raw material. They're complementary layers of the same picture, not competitors. Let's lock in the attribution half. Cost allocation tags are the labels that make attribution possible, and you activate them in the billing console. The CUR is the granular line item source sitting below Cost Explorer's charts. Together, those two fix MegaCorp's who spent what blind spot. So far, every tool has told us what happened. Now, let's meet the tools that tell us what to change. First up, Compute Optimizer, the machine learning right-sizing engine. It reads CloudWatch metrics for a range of resources: EC2 instances, auto-scaling groups, EBS volumes, Lambda functions, ECS on Fargate, and RDS databases. From that, it produces ranked recommendations, each one naming a specific alternative instance type and its projected savings. That's the key difference from a simple flag. It doesn't just say this is oversized. It says, change it to this, and here's how much you'll save. This is precisely the engine behind MegaCorp's sandbox downsizing recommendations. The look-back window is what separates Compute Optimizer's two tiers. After you opt in, Compute Optimizer analyzes the last 14 days of CloudWatch metrics for free. Turn on the Enhanced Infrastructure Metrics preference, and it extends that look-back to up to 93 days for a small per-resource fee, roughly $0.25 a month. That's 6 times more history, which catches monthly peaks the 14-day window would miss. The key distinguishing features of Compute Optimizer are the machine learning engine, CloudWatch metrics, and that optional 93-day look-back window. Here's what one of those recommendations actually looks like. MegaCorp had an M5.2x large, peaking at only 22.5% CPU and 35% memory. Compute Optimizer flags it over-provisioned and recommends dropping down to an M5.large, with an M5.x large offered as a more conservative middle step. The estimated savings are significant, and the risk rating comes back as very low. That's the value, not a vague warning, but a concrete swap with a number attached. Compute Optimizer is not enabled by default. You have to explicitly opt in, either per account or organization-wide, and after opting in, it takes roughly 12 to 24 hours to produce its first recommendations. Keep that in mind when a scenario describes a situation where no right-sizing recommendations are appearing. The service may simply not have been enabled yet, or it hasn't finished its initial analysis. The last tool is Trusted Advisor, the idle resource smoke alarm. It continuously checks your account against best practices across 5 categories, and one of those is cost optimization. Its cost checks catch low utilization, EC2 instances, idle load balancers, unattached EBS volumes, and idle RDS databases. That's how MegaCorp's forgotten dev environments and orphaned resources surface in a single view. Now, every account does get 56 checks for free, but those free checks cover only service limits and a handful of security and fault tolerance checks. None of the cost optimization checks are in that free tier. To unlock cost checks, the ones that actually flag idle resources, you need business support or above. So if a question specifies the free or developer support tier, those detailed cost checks aren't available. Think of Trusted Advisor as a building inspector who walks every room once a week and posts a list on the door. Lights left on in conference room 3, water running in bathroom 2. It finds the obvious waste. Compute Optimizer is a different job entirely. It's the specialist who redesigns the wiring to fit how you actually use the building. One spots the idle thing, the other tells you what to replace it with. Let's make the distinction sharp, because the exam leans on it. Trusted Advisor uses simple thresholds, like CPU at or below 10% for 4 of the last 14 days. It flags obvious idle waste with broad brush best practice checks. Its message is, this is idle. Compute Optimizer applies machine learning across CPU, memory, network, and disk, producing ranked, specific instance type swaps with projected savings. Its message is, change it to this. Trusted Advisor tells you something's wasteful. Compute Optimizer tells you the fix. 3 distinctions are worth locking in. First, budgets versus Cost Explorer. Any mention of notify or alert when overspending is always budgets, because Cost Explorer has no notification capability at all. Second, the CUR versus Cost Explorer, most granular line items, or an Athena query on billing data, is always the cost and usage report. Third, Compute Optimizer versus Trusted Advisor. Machine learning, CloudWatch metrics, 93 days of history, all of those point to Compute Optimizer. In each case, the requirement tells you which tool applies. So here's how MegaCorp goes from blind to governed in 5 moves. First, activate cost allocation tags so spend can finally be attributed. Second, alert, set per team budgets with thresholds so finance hears about trouble before month end. Third, analyze, use Cost Explorer to find the top spenders driving the bill. Fourth, right size, let Compute Optimizer recommend the specific downgrades. And fifth, sweep. Run Trusted Advisor to surface the forgotten resources still running from old experiments. From 180,000 euros of blind spend to a fully governed account, that's what these tools do together. Carry 1 line per tool into the exam. Cost Explorer visualizes and forecasts the analysis you open. Budgets fires threshold alerts, the answer for notify me before we overspend. The cost and usage report is your most granular line item billing data. Cost allocation tags attribute spend by team or environment. And on optimization, Compute Optimizer does machine learning right sizing, while Trusted Advisor runs the idle resource checks. Get those 6 straight, and this domain answers itself. Now let's put that to the test with a quick 5-question quiz. Question 1. A finance team wants to be automatically notified by email when their monthly sandbox spend crosses 80% of a set limit. Which service should they use? Is it A, Amazon Web Services Cost Explorer? B, Amazon Web Services Budgets? C, the Amazon Web Services Cost and Usage Report? Or D, Amazon Web Services Trusted Advisor? Run the keyword rule before you answer. This one is B, Amazon Web Services Budgets. The moment you see notify, alert, or threshold, it's budgets. Cost Explorer visualizes and forecasts, but it has no notification mechanism at all, so it simply can't send that email. Question 2. A FinOps engineer needs to run SQL queries with Amazon Athena against resource-level line item billing data spanning several years. Which source provides this? A. Cost Explorer's console dashboard. B. Amazon Web Services budgets reports. C. A compute optimizer recommendations export. Or D. The Amazon Web Services cost and usage report delivered to S3. Lock in your answer before I give it away. The right call here is D, the cost and usage report delivered to S3. It's the most granular billing dataset, built for querying with Athena or Redshift, with unlimited retention. Cost Explorer maxes out at 14 months and gives you a dashboard, not raw SQL. Question 3. An organization wants machine learning-driven recommendations that name specific replacement instance types and projected savings, drawn from up to 93 days of CloudWatch metrics. Which service is this? A. Amazon Web Services Compute Optimizer. B. Amazon Web Services Trusted Advisor. C. Amazon Web Services Cost Explorer. Or D. Amazon Web Services Budgets. Think about which qualifier matters most here. The answer is A. Compute Optimizer. Machine learning, CloudWatch metrics, and that 93-day lookback are its signature. Trusted Advisor only flags idle resources with simple thresholds. It never names a specific replacement instance type the way Compute Optimizer does. Question 4. MegaCorp's sandbox invoice shows one opaque total, and leadership wants to break spend down by team and environment from now on. What's the required foundational step? A. Enable Compute Optimizer. B. Create an Amazon Web Services budget per team. C. Apply and activate cost allocation tags in the billing console. Or D. Export a cost and usage report to S3. Got your pick? Let's see. It has to be C. Attribution by team or environment depends entirely on cost allocation tags, which you must both apply to resources and explicitly activate in the billing console. Until those tags exist and are active, Cost Explorer, Budgets, and even the CUR all still show one untagged lump. Pair team budgets and reports are useful, but they can't attribute without the tags underneath them. Question 5. Let's test a concept from an earlier episode. Back in episode 31, MegaCorp right-sized its fleet before committing to a purchasing model. Which model locks you to a specific instance family in one region, but offers deeper savings than the compute savings plan? A. Compute savings plan. B. Spot instances. C. An EC2 instance savings plan. Or D. On demand. Pause here if you want more time. If you said C, well done. The EC2 instance savings plan locks the commitment to one instance family in one region, while still letting you flex on size, operating system, and tenancy. That restriction is what earns you the deeper discount compared to the compute savings plan, which trades some of that savings for flexibility across families and regions. Okay, that's the end of FinOps tooling. Cost Explorer, Budgets, and Compute Optimizer. If it helped you understand this for real, subscribe so the rest of the Cloud Architect path finds you. Tell me in the comments what's stuck. Got an exam you'd like a full course on? Suggest it below. Your picks really do guide what's next. And if the visuals or pacing could be better, let me know. See you in the next one.